Big Bang. Time to switch gears again. So now we're talking about the Big Bang. That's the last topic we're going to talk about today. What is the Big Bang? The Big Bang is a theory that is the best explanation for the beginning of the universe, how the universe began. It states that everything was once contained in a small point. We call this a singularity. Then a rapid expansion released energy and began space and time. From the energy, matter began to fuse, and eventually this created the first elements of hydrogen and helium. Hydrogen and helium clumped together and formed the first stars. And then the universe itself is still actually expanding today. It's still moving apart, stretching from that initial Big Bang expansion. Now, Doppler effect, we're going to dive into that real quick because that has to do with some of the evidence for the Big Bang. Recall, the Doppler effect is when an object is moving, its waves are actually going to be altered or changed. Now, here's an example of a chemical element. Recall that in the middle here, we have an example of an elemental signature. This is an absorption spectrum. Now, whatever chemical this is the same chemical here and the same chemical here. In the object here, this object is moving, this object is moving. Because these lines are all identical and evenly spaced apart from one another, we can tell that this object is actually moving because its color has shifted to the red end of the spectrum. This color has shifted to the blue end of the spectrum. It doesn't mean that it's blue or that it looks blue. It just means that it is moved closer this way. So let's say this object was a green object. It may look light blue now. If this object was a red object, it may look yellow now. Alright, so how do we determine if something's moving towards us or away from us? So when an object is moving ahead of you or away from you, it's actually going to become redshifted. Its chemical signature will all move or shift this way. When an object is coming towards you, it is actually becoming blue shifted. It's going to be moving to the blue end of the spectrum. The rhyme goes, red goes ahead, or I guess the saying, red goes ahead, blue comes to you. The evidence for the Big Bang Theory, one of the heavy evidences is the redshifted galaxies. When we look out into the universe, we see that almost all the galaxies are redshifted, and this tells us that they are all moving away, that space is expanding. Another one of those evidences is the CMB, the cosmic background radiation. This is basically the radiation left over from the Big Bang. We call this the heat left over from the radiation of the Big Bang, and we see it everywhere in space when we look. No matter where we look in space, we see this radiation coming from every direction, everywhere. Now, the last one here that we'll talk about in our class is the abundance of elements in the universe. With how much time has gone by, we should see a very small change in the amount of hydrogen to helium to other elements in the universe. And when we take observations of the universe, this is exactly what we see. We see a change of hydrogen to helium, showing that many stars have gone through. They have used up some of that hydrogen fuel. They have created helium. Some have created large elements from that helium. And we end up having about 1% of other chemicals, of other elements out in the universe, starting the Big Bang, having much less than that. So according to measurements, estimates, temperature, abundance of elements, and the size of the universe, how old is the universe? The universe is about 14 billion years old. Alright, that's everything for this unit. Hopefully you're studying your notes, you're studying your guides, you're studying your flashcards, and you are preparing well for this test. If it helps you, go ahead and listen to this video over and over again until you've got all those concepts down. Feel free to Sorry, feel free to zoom in, zoom out, skip ahead, skip back, and get your studying on.